So we're looking at electromagnetism. And from grade 9, you might remember that if you have a cell, and that cell is connected to an iron nail, and you wrap the coil of that wire around this nail, that if the battery is connected, we can pick up some iron filings with this electromagnet. This is an example of an electromagnet that you might have been exposed to. Electromagnets are used in a large scale also in, for example, scrapyards, where they place an electric current through a large magnet, and that magnet is strong enough to pick up a car. It's made from metal. Now, you don't want that magnet to be working all the time. Otherwise, in the morning when you get to the scrapyard, you'll have cats with metal collars stuck to that magnet. You will have everything that's metallic stuck to that electromagnet. So we don't want it to work all of the time. Therefore, if we disconnect the battery, this iron nail is no longer a magnet. So we see that electricity can cause a magnetic field. And what we see here is that if we have a current, and now this blue line is a current carrying conductor, the current is flowing in this direction. We see that the magnetic field around it, remember these lines are imaginary, and these lines never touch one another, but they are perpendicular in their plane compared to the conductor, which means there's a 90-degree angle between this blue conductor and the magnetic field. So as you can see with a current carrying conductor, that magnetic field is going to be stronger the closer we get to the conductor. And the moment that there is no current flowing, that magnetic field no longer exists. So these are the basics behind magnetic fields. Now we can also go and determine the direction of a magnetic field. We can use this example where we have a straight conductor, and the direction of the magnetic field can be determined with the right-hand rule for straight current carrying conductors. So if you were to use your right hand and hold the current carrying conductor in your right hand, the direction in which your thumb points will give you the direction of the current from positive to negative. So if you look at this example, we know that current is flowing downwards, which means positive is over here, negative over here. This means your thumb will be pointing downwards. Then the direction of the rest of your fingers will indicate the direction of the magnetic field. If I were to go and draw this, and let's say now this indicates a current carrying conductor coming out of the screen. If we have our magnetic field lines around it, then we know that our magnetic field lines will be in this direction and this direction. If we know that the magnetic field around this current carrying conductor looks like this, where the arrow now indicates it's going into the page, we know that the direction of the magnetic field will be in this direction and over here in this direction. We can conclude that if a current carrying conductor, and remember this is now a straight current carrying conductor, is coming towards us, we see anti-clockwise movement here of the magnetic field. If the current carrying conductor is going into the screen or the page, we see clockwise movement of the magnetic field. So that's very important to remember, that the magnetic field lines here form concentric circles around the conductor. The magnetic field is anti-clockwise when the current is flowing out of the page, and clockwise when the current is flowing into the page.